Hello guys, welcome to yet another episode of AIML Talks. So today we'll be talking about Seaborn. Seaborn is built on top of Matplotlib, and Matplotlib will give you basic visualizations, but Seaborn will give you advanced visualizations within a single line or two to implement that you need to do. So it will be just you need to work with Matplotlib and Seaborn together to create some advanced visualizations out there. So let's move to the code round and we will see how it works in the real life. Okay. Hello guys. So the first thing that we need to do out here is install the libraries. So the libraries that we need to install out here in this tutorial are Seaborn, Matplotlib, NumPy, and Pandas. So you can do the installation by pip install Seaborn, Matplotlib, NumPy, and Pandas, and then you need to import the libraries. So you need to import Seaborn as SNS. So this is the SNS is the way we will normally do in importing Seaborn. And again, the same thing, matplotlib.pyplot as PLT, NumPy as NP, Pandas as PD. And then, this is matplotlib inline. And then we will set a style, okay, for all the, plots. So we are setting a theme that this is the SNS.set theme. So there are multiple themes that you can use. So, that instead of white grid, there are other options also that you can check and use it out. Okay. So now SNS is Seaborn has some inbuilt data sets that you can import. One is tips, another is flights, another is iris. Then there is a Titanic data set also that if you wish to use, you can you can import them and use it while trying it out something. Okay. So let's run them. Okay, and then we will see what is there in the tips data set. So we'll run the tips head. So tip has the total bill, tip, sex, smoker, yes or no, day, which date is, time, and size. Okay. Similarly, the iris, famous iris data set that is there, sepal length, sepal width, petal length, petal width, species. And then there is a flight data set that we will be using for our time series data. Okay. So this is monthly wise data of a flight. So let's move to the first plot, that is distribution plot, and we will be plotting histogram and a kernel density estimate that is known as a KDE. Okay, so again you can see that we are using Matplotlib a lot in this figure, in this code. So everything will be used from Matplotlib itself, how we do figure and subplotting part. To create a subplot here, so what we are doing is we need to mention the first, we need to mention the figure size. Though this is the overall figure size, that is 10 by 4. Okay, then we are doing subplotting 131. So 131 means 1 rows and 3 columns. Okay, and this is the first subplot. So the first subplot we are doing a histogram plot. So sns.histplot will give you the histogram of we are creating 20 bins of that tips part. Okay, and then the second part we are doing again a KDE plot. Okay, in the second part, and the third part again we are doing a hist plot with KDE equal to true. Okay, so basically what this code will do is it will create a figure in which there will be three subplots, and then every subplot will have a different figure. Okay, so to create a histogram plot in Seaborn, we will do sns.histplot. Okay, and to run a KDE plot, we will do sns.kde plot. So remember these two things. And if you wish to do within this histplot, you want to draw the KDE equal to true, that also can be done. So let's run it out. So see, basically we have got one plot in which there are three subplots. One is histogram, another is KDE plot, and third is histogram with KDE. So basically this is something that you want to look that how it looks like, how the data distribution looks like in your actual data frame in whatever data that you have been using. So, and if you want to show some EDA to the customers or anyone, you can show like this. Okay. So now let's move to box plot and violin plot. So basically, like a box plot and violin plot are used for outlier detections and see the distribution of how the data distribution looks like. Okay, so we are doing them some side by side comparison just to see how both of them are using. Okay, so let's see. Okay. So see, again to use this box plot, you just need to write sns.boxplot. Then you need to give the data, which data you want to use. You are using tips data instead of, let's say, tips data frame. You are using data frame, some data frame. Then just give the data frame name, and then X you need to give the column name, and then Y also you need to give the which column name you want to use. Okay. So again, in this sub, we are doing two subplots. Okay, one row, two columns. Okay, this is the first subplot and this is the second subplot. Okay, first subplot will be the box plot part, and second subplot will be the violin plot. Okay, so let's see how it works. So see, uh, this is how the box plot looks like. So box plots will help you identify the outliers. So see, in this Thursday, there are a lot of outliers after 30. Normally the data lies within 8 to 30 range, but there are certain values that are outside of this range. Same on Friday there is one outlier that has 40, total bill is 40. And Saturday also the bill is some of the bill are like above 45 and all. So these are sort of outlier values. Okay. And see, when you look into the violet plot, you can see that the high density part is in this 10 to 15 range, sort of on every day. A little bit increasing on when it is on Sunday. Otherwise, it is normally it's the same thing. Okay. So let's move to the next part. So again, so we will be doing some relational plots, we will be doing some scatter plot between two variables. So we want to check, well, how the relationship between two variables looks like. So to do that, you can do one scatter plot and line plot also. Okay. So again, SNS dot scatter plot will give you the scatter plot, and SNS dot line plot will give you the line plot. Okay. So let's run both of them. So see. Uh, in this scatter plot, so we are looking at difference between the data is of tip and the total bill. Okay, and we are looking at the data in which the hue is mentioned as lunch and dinner. So basically, see, this is the blue version is the lunch version, lunch tip and total bill, and the orange one is of dinner. Okay, so this is how this scatter plot looks like for total bill versus tip. And the line plot that we had was for the data was flights, and we wanted to check for each yearly thing, how the passengers uh, total number of passengers were there. So see, it's a simple line plot. Based on this line, you can say that okay, this is the increasing graph, and the number of passengers are increasing year on year. Okay, so now let's move to the next part. So we will be doing some categorical categorical plots out here again. So we will be doing some bar plot and point plot. Okay, so we will be doing a relationship between we will show this relationship between a continuous variable and one or more categorical variables. So basically, in this again we are creating two subplots. So the first part we are showing that on which day the total bill is like how much. Okay, and the second part again is a point plot. Okay, so let's run both of them and see how both of them look like. So see. This is the first part is the bar plot. This is again total bill on total bill on Thursday is like this, and this is the point plot. The point plot is basically again we'll be looking at how the data uh, data is divided between lunch and dinner. So see, you can see that most of the lunch bill is on the lower side, and the dinner bill is on the higher side. So here it is categorized, and here it is not categorized in this bar plot. So this hue is giving you that data. Okay. So now let's move to the next part, the regression plots. So it will show so SNS those regression plots will work with uh, PLT dot subplot. So it does not natively support hue parameter. So basically, when you want hue something like this, this part is there. So it doesn't support basically, and you need to manually split the data then and plot against each category. But when you're doing this SNS.lm plot, so it will it will create its own figure, and it supports the hue parameter also. So basically, when we are trying to create this thing, the SNS.lm plot, it can't be used with this PLT dot subplot. Remember this part. SNS.res plot will be working with PLT dot subplot also, but not the LM plot part. So this is the major difference between both of them, and you can just run both of them and see how it is working. So see, so the first part, there is no hue parameter as such, and you can't differentiate the third category on which day it is or what it is about. Okay, and in the LM plot, you can differentiate between the lunch and dinner part. So see, blue is looking at the lunch data points, and the orange is looking at the dinner data points. Okay, but and if you wish to use it in some certain subplots also, this will be used. But when you're trying with LM plot, it won't be useful there. You will be facing some errors there. So don't try that part. So now, okay, so now let's move to the matrix plots. So matrix plots is basically we can use this to visualize correlation matrices. Someday I'll be creating correlation matrices, and how this label encoder and all these things work. Currently just go through it. So this SQL has this label encoder, and label encoder is used when you are doing some classification, you have some categorical values and you want to move it into numerical values and all those things. So those can be used. Okay. Uh, so basically see, correlation matrix requires basically both of them to be numerical feature. If it is not numerical feature, it will not show you correlations. So currently this data will look like a highly correlated data, because sometimes what happens is uh, this data is a numerical thing, but we'll see how it looks like. Okay, for your data point, it for any other data point it may not work, but for this particular data point, it's like this. So to find to use the correlation matrix, just use that df core. This is the basically correlation matrix, and uh, uh, to plot this correlation matrix, this can be IRIF is a DF out there. So instead of IRIF, this can be your data frame dot core correlation, and then to generate the hit plot heat map, just type ss dot heat map, and then pass on this correlation thing, collision matrix, and then annotate it equal to true, and then CMap you can change up based on your use cases, and then till how much decimal points you need. So we want till 2, so that's why we have put an dot 2f. Okay, so just run it out. So see, so we wanted 2 decimal points, so that's why now we have heat map of 2 decimal points. So this heat map shows a correlation between this sepal length and sepal length. These are two the same thing, so that's why they are highly correlated. But sepal width and sepal length, they are not that much correlated. That is minus 0.12. So again, these zero point 0.9 petal length and then petal width. Petal length and petal width are highly correlated. So you can see a number of 0.96. Similarly, petal length and species is again highly correlated out there. Okay. Uh, so this is how you can plot a heat map. This will be highly useful to plot your correlation matrix out there. and you will check like which of them are correlated to each other, which of the variables are correlated with each other. So now let's move to the styling and customization of the Seaborn plots. So Seaborn has two specific one is style and another is palette. So style will control the overall look of the plot. Basically it will help you in changing the background, grid itself, and then the palette will basically will be useful to control the colors used in the plot. So there are several examples that you can use, like dark grid is there, white grid is there, dark is there, white is there, ticks is there in the style part. And for the palette part, viridis is there, deep is there, pastel is there, color brand is there. Okay, so it will be used whenever you want to use the background and structure, and this will be mostly used when you want to change the data points, bars and lines. So remember, whenever you wish to change a data point or lines or bars, then you will be using palette. And if you want to change the overall look and feel of the your plot, then you will be using style. Okay, so see, these are the options that you have. So again, I'll be using this sns dot load data set. Then style I mentioned is like that. So you can set a style. So you can change this style and it will look something else. So just run it. Let's run this part. Okay, so see, we have chosen style is dark and palette is pastel. Okay, so we can change it here. So we'll make it white grid, and instead of pastel we can make it the dark. Okay, so see, now this style, the background has also changed, and the palette also has changed to dark. So earlier the background was plain and it was little bit grayish thing, and now the background is white and the palette is dark. Okay, so you can play with the other things that you have. Just a minute. Yeah. So you can play with the style and palette whichever you feel like, and then based on your requirement you will be using it. Okay. So now so whenever we are whenever we are creating a subplot, so subplot those can be bifurcated. We can plt dot subplots when this is 2 by 2 matrix and this figure size is 10 comma 6. Okay, so this figure is basically the entire figure, and axis is basically that the axis, if it is 2 comma 2, so then it will be there will be four sub 4 matrices. You can assume four matrices. The first one is 0 comma 0 will be the first element of it, basically first subplot, topmost subplot, and then 0 comma 1 will be the top right of subplot. So basically this axis will be useful whenever you want to use, let's say if you want to use a particular axis, and you want to you want to do anything with axis 1 comma 1, and then so that part you can mention as that we want to color change the color of that axis to something, and you want to give some attributes to it, that can be done. Okay, so see, we have put some palettes here, and we're trying to print out them out here. So all these palettes will be different. So let's see how it looks like. So see, so what we have done is for every axis we have changed the palette. So the first palette is deep, second palette is little bit muted, but the color from this and this is little bit different. And then there is a pastel. Okay, so pastel is little bit lightish, everything will be little bit light, and then the palette bright is everything will be quite bright with respect to the others. So depending on your use case, on your feel good factor, you can choose any palette that you wish to do. Okay, so now let's move to the next part. That this is facet grid. So facet grid is basically this is used for like visualization of multiple subsets of data. So basically what you do is this you can mention two columns, one column and row. So if time has different times and smoker has different values, so it will create multiple advanced visual basically multiple plots for them, and every plot will be a separate individual plot. So let's try to run them and we'll see how it works. So see what has happened is, so we had given this row is smoker. So smoker has multiple values. Smoker is yes and smoker is no. Time has multiple values, lunch and dinner. So again, what it will try to do is, first it will try to take smoker value 1, the smoker yes, then again it will take the time value, time lunch and then time dinner. So one plot it is doing for smoker yes and time lunch, time equal to lunch. Another plot it is trying to do is smoker equal to yes, time equal to dinner, and same thing it is doing for a smoker no, time equal to lunch. Okay, and then smoker no, time equal to dinner. So for total bill, so this map.data frame, basically map.data frame is what it is doing is basically it is mapping this plotting function, this SNS scatter plot, to all of this subset of the data. So there are four subset of it, because every value has two values, so 2 into 2 is 4 values. So basically and then this add legend is basically it is giving the legends, what is the name of it. Okay, smoker yes and time equal to lunch. So this legend is showing for that. Okay, so now let's move to the some other plot. So this is a joint plot. So joint plot is basically, again, you can use this joint plot using SNS.joint plot. So whenever you want to use visualize the relationship between two continuous variables, you can use joint plot. This again, we are just using the tips data, and then x is total bill, y is tip, and we want to show some regression relationship, and height of this plot is, we have kept it as 5. Okay, so see now joint plot, basically what it will give you, the individual distribution also. See, this is a scatter plot. In this the total bill is in the x-axis, and the y-axis gives you the tip. So the total bill distribution is also there. So this distribution, the joint plot will give you that total bill distribution. So see, it is giving the distribution of this, the the maximum of it lies between around 15 to 17 total bill. For the tip range, again the maximum ranges is around 2.5 and something like that. So basically it's giving you distribution of both uh, total bill and total tip also, and then they're combined. This is the combined portion also. Okay, so basically it is giving you both a distribution of tip and distribution of total part also, and then it is there in the combined part also. Okay, so now let's move to the pair plot. Okay, so pair plot will create a grid of scatter plots for pairwise relationship between all numerical columns of. So whenever you are doing uh, pair plot, so it will, if you are having 10 numerical plots, so it will try to create 10 C2 plots out there. So because it will have every plot will be a individual plot. So it will create a 10 and then if you want to highlight a specific thing, then you can just mention hue equal to specific. So this will be like a color, it will hue equal to species. So basically it will color the a specific column. So if there are two variables in it, then it will have two different colors. If you want to have uh, if you want to have there are 3 or 4 values in it, then it will be four columns of it. Okay, so the diagonal diagonal matrix will show you the KDE of each variable, basically all the kernel density estimates, all the diagonal pair plots will be showing the KDE of that. Then the other non-diagonal will be displaying the scatter plots of the pairwise relationships. Okay, so let's run it, and then we'll say so we are using the uh, iris data. So iris I have printed previously also, so I'll just comment it out. So just I'll use the SNS.pair plot iris. Hues is basically species. Okay, so see, so this is giving the KDs, and the others are non-KDE versions of it. Basically, they are with doing the scatter plot. And then like the species were 0, 1, 2. So there are three different colors here. Okay. So you can see petal sepal length and then sepal width. So how it looks like, everything is little bit separated here. So this is how your pair plot will look like if there are some relationship between both of them, it will show you that also. Okay, and the last part of it is time series plots. So time series is basically time data after after a while how the let's say yearly data, if you want to know about yearly stock price of Reliance or monthly stock price of Reliance, you will be plotting it in a graph and how it looks like. So basically I've used this group by function to sum all of the yearly passengers, and then this yearly passengers again we have just plotted it out here. Okay, to it will be basically line plot, because it's a straight line every few days, few days or whatever with your time frame. So based on your time frame you can put that value out there. So here we have taken a year range, and for that we have just kept a marker also just to show that this is the value wherein there is this data is there. Okay, so see, this is the time series plot. So again, you can do the same x level and y level. The year and year will be x level. So just in PLT title, again this title we learnt in Matplotlib. So this same, everything is same in in Seaborn. The most of the things you will be using will be of uh, Matplotlib, and only one or two plots that you want to use, whichever plot that you want to use, you can use using SNS. So here we were using line plot. So basically line plot, then we are giving marker also. So it is looking little bit nice. That's it. So I hope you liked the video. Do like, share and subscribe to my channel.